Hi, it's Tim and welcome back to the corner. Today we have got the 1551 back on the bench, and the reason is because these have arrived, and these are our Mark II replacement paddle boards that connect the 1551 to a +4 or a C16. So shall we take a look at them and put one together? Let's do it. So just to recap slightly, the 1551 is a parallel disk drive for the +4 and C16 series. Now it achieves its parallel status by using this paddle, and here is the original casing and the original board. So the board sits in there like that, and it has this metal shielding. Which we won't worry about for the moment. And this paddle had failed. There are two chips on it. One is a PLA and one is a 6523, which is a tri-port adapter, and it's a 28-pin chip, and the problem is you cannot get them. The only way to find a replacement 6523 is off one of these. But this drive and a number of other machines have a 6525, which is also a tri-port adapter, and this adapter board that I built last time takes one of those, a 6525, which you can get, and it basically does the same job. It's an identical die to the 6523, but the pinout is different, and of course it's got 40 pins instead of 28. So I built this little board. It's just got some, that's a debug wire for the scope, and I tried to get the dimensions as close as I could, but of course this being a longer chip, we had to extend the length of the board, and then there was a problem with this weird 15-pin connector / 17-pin connector, and 17-pin connector / 16-pin connector. And you see the connector itself is replicated there underneath those two capacitors as a regular pin header. It's an odd connector, it's an odd dot pitch. Yeah, yet another weird Commodore connector that you can't get. So basically I pulled that off and mounted wires onto essentially just pin headers, and I didn't quite get that right, so that's a bit of a bodge. And so we come to the Mark II, and let's just get this out of its plastic case. This of course came from our sponsors PCB Way, although they did not pay for these boards. I bought them myself. So these are a little more than $5 because they are bigger than the sort of minimum size. So, but they are not very expensive. And I made a number of changes over this board. This one has got, it's got an EEPROM as the PLA, and that's on a little adapter that I built just from a piece of Vera board and some wires and stuff. and you can download the ROM code off zimmers.net. And I built that up and we tested it. The downside of building this little tower is that it does not fit into the +4, especially when you've got it in a socket. But the EEPROM is not the same pinout as the PLA, and this is the original PLA that came off this board. Try that out. And here is a replacement PLA, which is actually a Philips. You can get those readily online. This is a 251641-03. Now the 03 is important because the -02 is the PLA that goes inside a +4, and it is not the same. So this is the Mark II. It's slightly different. I have got 2 rows of connectors in here. That is because so we can either put in a PLA in that set of pins, or we can put in an EEPROM in that set of pins. So basically I've incorporated this little adapter into the board, so you can take your pick, one or the other. And then the 6525 goes here. I've given a choice of 2 connectors. So this is the 17 pin odd thing which is off that, so you can pull that off your original board and then solder it straight into there. Or this is a 16 pin version, so one of the ground pins is just taken off, and that takes a standard 0.1 double header. And I added a hole for a cable tie so that you can tie it down, just to make it secure. And I have 3D printed a replacement case that is slightly longer and slightly different profiled, so that, there we go, we can fit that in there. Hole for the screw, I've still got the screw. And that will be a replacement paddle cartridge. I'd like to thank PCBWay for sponsoring this video. Whether it is building shared projects like this one, or your own PCBs like this one, PCBWay is the ideal place to get your prototype PCBs from. But they don't just do PCBs, they also do 3D printing, CNC machining, sheet metal work, flexible PCBs, advanced PCBs, whatever you want in the PCB field, PCBWay do it. And they've been around for 10 years now, so they know what they're doing. $5 for just 10 boards means that if you're like me and you go through 4 separate prototypes on one project, that doesn't matter. $5. Check them out, www.pcbway.com. Okay, so here we go. Let's put these in first. I'm down to just 10 pin sockets on the 40 pin jobs. Now, what shall we go for? I think on this one I'm going to go for the real PLA. Right, I'm going to leave that off to start with, purely so that we can test it, and if I need to build another one then I can put it on that. There we go, and the earth just needs to be tacked to the earth somewhere on here. And that's it done. This will go on here eventually, not for the moment. So let's hook it all up and see if it actually goes. Okay, we have it plugged in. So here's the +4 TV power paddle, and 1551 is currently switched off. So let's power it up. Get this in the right order this time. Drive on first, and then the +4. Now the green light is on, the red light is off. That green light doesn't show very well from a side angle. You can see it head on, but not so much from the side. So the 1551 is device 8. We should be able to talk to it by a simple DS dollar. Huh. Ah, now that's interesting. The error light is flashing, 4 flashes. 1, 2, 3, 4. 1, 2, 3, 4. And +4 is kind of locked up. So is that the interface or is that the drive? The drive is saying that there was an error, so it could be that that's not working, or it could be that that's not working. We have our program that we used last time to test this. Let's get that out and see what that does. Okay, Pi 1541. That is plugged in the serial port. This is device 9. This is device 8. This is currently switched off, because the program that we load on there wants that to be switched off when we first run it. This is switched on. Now we should be able to talk to that as device 9. So directory U9. There we go, and the program that we want is up here, 1551 test. So we can deload 1551 test, comma U correction U9. Loading, 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 loading. Ready. Right. 1551 should be connected but powered off before we start. That is, and it's connected. Press return to continue. I think port A and port C are basically not connected on that, so that's okay. It's port B that goes to the actual thingy. But we will continue. Okay. Okay. Okay, this is looking good as far as the interface is concerned. Port C came out to bad. I think that's okay because it's port B that's being used. Drive is configured as 8. Power on the drive. The light is on, you can't see it very well. Press return. All okay. Ignore bad unstable on port C. Okay. Okay. Huh. And it's done it again. 4 flashes. Meanwhile, the +4 appears to have crashed. Let's open up the drive and have a look inside. So this is a matter of 4 screws as usual. Right, I don't know entirely what we're expecting to see. So talking to the 1551 from the +4 seems to lock up, seems to crash. I would guess the 6510T is working because the drive seems to respond, and it did the flashy and it needs the CPU in order to do the flashy. I don't think it's the drive logic, which is this stuff here and this stuff, because it's communications that is getting stuck. So I'm going to suggest we swap the 6526 from here, sorry, 6525 from here with the 6525 from here, and see if the problem moves. So if this is faulty and we put this into here, then that should be faulty. Okay, that sounds like a plan. So let's put this back together and try it with the other chip in. Power on the +4. It's not U8, is it? It's U9. Silly me. Device not present. Okay, well that's because it's switched off. Okay, this is switched off. That is on. Let's see what we get. So far it's looking the same. Power the drive on. This is going to be the moment of truth. I think this was the point at which it failed. Yep, that is exactly the same. I wish I knew what those 4 flashes meant. Unfortunately, there is no service manual for the 1551. Okay, let's turn this off. Ah, turning that off, it came back with the device not present. That's interesting. So, there is one other option, and that is the PLA. So let's try swapping the PLA over. Okay, so that's the other PLA. We'll just do the simple test. Four flashes. And it's locked up. Okay, spotted it. Now I don't know if you can see on this connector going from this end from pin 17 between there and there, there's a connection. Now if you look on this connector between there and there is no connection. So that's it. Unfortunately, it's under the top side of this. So in order to fix it, I am going to have to take that connector off. Or I could simply cut it on one of these, which I have done there, and build up another one, because we've only just wasted a couple of sockets. This is why you buy 5. I've got to fix this connector anyway because, well, a wire's come off. Because one of the pins came out. So I'm going to need to rebuild that. So we've got another box from PCB Way.
I didn't get that. Could you try again?
Shut up, Siri. And here we've got our hopefully final version of the PCB. Again, it's paid for by myself. So this time we went black, because I find it helps if you revise a PCB, make it a different colour. That way you're not going to get them confused or mixed up. Now the obvious thing is I've made these cut out here so that we can plug cartridges in, and I've shuffled the components a little bit because the case was cutting stuff up and there wasn't really enough space for the bar. So yeah, I've moved that inside a bit and that from there to there. And of course I've fixed the problems of the pins being shorted out. So that should no longer be a problem. Let's build it up. And just transfer the chips. So I'm very much hoping this is going to work and there is not another cock up on the board. Right, that's in nicely. Let's bring out the +4 and hook it up. Right, here we go. Everything is plugged in. Let's see what it does. Well, it starts, that's a good sign. And it's talking. So we can try the floppy. I have no idea if this is a working floppy. Oh, yes. That is working. So let's turn this off so that we can take it out. This is the PLA version of it. We need to try the EEPROM version of it, which is in the opposite socket, just so that we know that they both work. There's no reason that they shouldn't. So I will make one of those up and we will try it. So the second option is built up. You see we've got the WinBond, I can't even say it, WinBond. We've got the WinBond EEPROM in the second set of pins compared to the actual PLA. So that is our alternate option. Let's plug it in and see if it goes. Power's off. Power on. Power on. Huh. That's interesting. Now that's interesting. +4 just died. Let's power it on. This is with the thingy out. And we've got a black screen. This was working before. Okay, well, in order to show you this working, I'm going to go to my C16. We will repair this, but we will do that in another video. Okay, very quickly I decided to try something, and because I have literally 3 feet away from me a spare TED, I've taken the old one out, and here's the lid, and put the new one in. It was tested by Steve from 8-Bit Retro Refix some time back. We saw that in another video. So let's just try it. And it's working. So unfortunately that TED has succumbed. Okay, so we will do our test. Turn this off, turn it off at the plug. Plug this in. Right. the drive. So here we go. This is the EEPROM version. Huh. Just hit reset. No. You know, I tried this afternoon and it worked perfectly. Bugger, bugger, bugger. Yes, okay, I admit it. I had to put a bodge wire on because I didn't get the interface quite right. Does seem like it's a connection. Right. So that is communicating with the drive. Let's put the disk in. Directory, and there is our disk directory. So that is working. And that is working. What I will now do is basically a version of this that allows for this big huge connector there. If you're just transplanting a drive from an old adapter to a new adapter, then you probably put the original connector on and you would be connecting the original connector to these pins, which would be a much lower profile, and so that will fit quite nicely using this case. I'll post this onto Thingiverse and link that in the description. The other connector is for typically an IDC ribbon cable type connector. So the difference between this and this, essentially this ribbon cable, it's a 16-pin dual inline ribbon cable, and it starts from pin 1 and it goes to pin 16, whereas this starts from pin 3, well, it starts from pin 2 and goes to pin 17. So what you have to remember with this displacement, it's ground at both ends. So really what you just need to do is take the brown wire from here, which is the ground on pin 17, and move that to the opposite end. There we go. It's all on it's all on this one row. So ground would need to move to that side, and then it can plug into that as a ribbon cable, and you can then just sneak the ribbon cable out. So a little hole there is for a cable tie, so that you can stop this from wandering about. So just to finish up, this is yet another iteration. We've fixed the issue with the EEPROM socket. The PLA socket works as before, and this is the version that is going to be in the shared projects list. So I'll put a link to that in the description, and you should be able to get that by the time this video is out. This is the EEPROM version. I'm not actually using the EEPROM version. I have tested it and I do know it works. And the final PLA version is plugged in here. And I've attached the pass-through, and we're using the Script Plus cartridge just to show that the pass-through works. So I'm going to power everything up. Drive on, +4 on, but this is just purely to prove that everything is working. So I'll put the disc in F3, and there is our test disc with the exciting block program on it. And as you can see, we have 3+1 on key F1, Script Plus on key F2, and Script Plus of course is the cartridge. Hit F2, and there we go, Script Plus copyright 1983 Precision Software. Okay, these will be available on Thingiverse. Again, I will put a link. That is the regular cartridge for if you actually manage to do a low profile cable, and that's basically just an extended version. And that's basically just an extended version of the regular cartridge case. And then this is the tall version that copes with my big bodge blooming thing. And I will put, yeah, not very pretty on the inside, but I will put the cartridge in there, and then as far as I'm concerned, at least for this particular video, that is it. So once again, thank you for watching, assuming you've got this far. If you haven't got this far, then you are going to miss out on the imaginary $5 million prize. Thanks to my Patreons who are scrolling up the screen. They really do help keep the channel going. Please check that out, www.patreon.com. Thanks again to PCBWay for making all these PCBs in literally every colour that they do, I think. Apart from white, I've got yellow ones, I've got green ones, I've got blue ones, I've got red ones, I've got black ones. No, I don't have blue ones. And I will see you next time. See ya. Bye.